Pressure measuring devices problem solving. Problem number 1. A differential manometer is given. Calculate the pressure between point A and point B. Remember that differential manometers is a type of manometer which only measures pressure differences. So as you can see in the problem, I will be zooming it. From point A, there's one differential manometer. And from point B, there's also another differential manometer. So in the figure, we'll be seeing that from point A up until this point right here, oil is present. And mercury is present from this point up until this point. And again, oil is contained from this point up until this point. You have to remember that in pressure measuring devices, you have to fully understand the concept of the second law of Pascal, which means when the fluid is going up, pressure becomes subtractive. And when fluid goes down, pressure becomes additive. And the pressure of the same fluid at the same elevation is always equal. Now, my first tip to you when you are solving manometers, you have to find the common points wherein the pressure is equal in the same fluid. So it means if you will be looking closely to the figure, I have provided orange colored numbers so you can see where the pressure points are equal. So from this point up until this point, pressure is the same and also the fluid is the same. I did not consider going from point 1 to point 2 even though the fluid present in that certain part is still oil, because there has been a discrepancy from point 1 to point 2 in the terms of its elevation. So since it goes downwards, there has been an increase of pressure. So after going to point 2, find again a point wherein the pressure is the same. So projecting it into this point, that will be again point 2. So since going from point 2 to point 3, there has been an increase in elevation, so that means pressure will be subtractive. And going from point 3 to point 4, there has been again a change in the elevation from point 3 to point 4, and that will be seen as x plus 24 inches. And from this point forward, it will be the manometer reading of pressure P. So from what I said before, you have to see in the illustration, this will be your working equation for the whole problem. So pressure A, this part, pressure from point 1 to point 2 will be starting from this up until here, subtracted by pressure from point 2 to point 3 in mercury will be seen in this part. So point 2 to point 3, subtracting again the pressure from point 3 to point 4 since it's elevating, equals the measure reading at point B. Since pressure is not given from point 1 to point 4, you have to expand the formula for pressure, and that will be given as pressure is equal to the specific weight multiplied by the height. So from point 1 to point 2, you have to consider this part, which means the specific weight of oil multiplied by the height of the oil. Then subtract again due to its elevation. So specific weight of mercury multiplied by the height of mercury minus the specific weight of oil again multiplied by the height of the oil is equal to pressure at manometer B. Since the specific weight of oil and mercury were not directly given, you have to further expand it as the specific gravity of that certain fluid multiplied by the specific weight of the reference fluid. So for this problem, you may use water as the reference fluid. So to avoid confusion, you may separate all pressure computation. So pressure from point 1 to point 2 in oil fluid will be solved using this equation. So this will be the specific gravity of oil, and this will serve as the specific weight of water, and this x plus 12 was the elevation from point 1 to point 2. Now, as you may see this red colored font, this is actually the conversion factor for your elevation. Since the specific weight uses feet, you have to align all units in order to solve this problem. And thus will give us pressure from point 1 to point 2 in oil as 4.78 for quantity x plus 12 pound per squared feet. Continuing with the solution, pressure from point 2 to point 3 will be given as 13.6 as the specific gravity of mercury, multiplied by the specific weight of water, multiplied by the elevation from point 2 to point 3, which is 12 inches, multiplied by the conversion factor will give us 848.64 pound per square feet. Lastly, the pressure from point 3 to point 4 in oil fluid will give us 0.92 as the specific gravity of oil, 62.4 pound per cubic feet, and the elevation will be x plus 24 multiplied by the conversion factor, thus giving us the pressure from point 3 to point 4 as 4.78 for quantity x plus 24 pound per square feet. Now you may look at the illustration again to be able to see the difference in the elevation. So this will be from point 1 to point 2 we used x plus 12, from point 2 to point 3 we used 12, and from point 3 to point 4 will be x plus 24. So that may not confuse you. So to substitute all the values in the working equation, pressure from point A plus the pressure from point 1 to point 2, pressure from point 2 to point 3, and the pressure from point 3 to point 4 is given in these values, equals pressure at point P. Thus giving us the pressure difference, pressure A minus pressure B, as 906.048 pound per squared feet.